Hello everyone, welcome to ML with AP. We are continuing with our playlist on NumPy. Today we are going to discuss the various attributes related to arrays and the arrays, how the indexing works for the arrays, how slicing works, how we can shape and reshape the arrays, and at the end we'll also see how we join or split the arrays. Essentially, we are going to discuss all the various operations which can be performed on an array and which you typically expect out of a data type, standard data types. Let's learn. Import it as NP, import NumPy as NP, pretty standard. What we are going to do over here to give you the examples of the attributes associated with the array is that we are going to create three arrays. The first one is a one-dimensional array. Why it is a one-dimensional array? So np.random.randint we also saw in the last video. What it is going to do is it is going to generate size 5, that means 5 elements of the array. And what is the, if you do not mention the lower number is by default taken as 0 and this is the higher. So between 0 and 10, generate a 5 integer, right? Over here, the second array x2, we have passed the size as a tuple 4 cross 5, so it's a 2-dimensional array. Similarly, the third will be a 3-dimensional array, and what value of the elements will be populated with? Random integer, okay? And the third will be 3-dimensional, 3 cross 4 cross 5. Let's run it. Okay, now before we go over there, in the last video also we discussed this dot operator, right? So with dot operator, you can expose or you can make use of various attributes and methods. Let's see what those are. Let me just go over here. Yeah. So as I was saying, with any Python object, you can run, if it exposes a dir function, you can run the dir x1. So x1 is what? X1 we have defined as a NumPy array. So all the attributes and methods which are associated with a NumPy array will be listed down over here. Okay. Now, if you run this, let's run this and see. At the very beginning, you will see this double underscore ones. These are the used internally by Python. We can also use it, and maybe I will show you how to use it, but these are mostly used internally. But when you come down over here, all the ones which you see, it's apart from this double underscore dunder ones, these are either methods or attributes. Methods are something which is a function call. It's a callable function call. We already discussed this in the last video. Attributes are the values or the characteristic or the features stored of that particular object. So x1 will have, and there is no easy way to determine that. Probably I will show you how to determine between a function or a method and an attribute. But the crucial difference is that attribute, you do not append it with parentheses. With function or method call, you have to append the parentheses. So let's see. Over here, as I can show you, let me show you d type. So x1 dot d type, if I write x1 dot d type is an attribute, right? So it will show you the data type for x1 is int64. Let's say, and x1 dot, let me see, argmax over here. Okay. If I run argmax, I know that argmax is, I gave this example in the last video also, it's a function call, it's a method, so I have to at the end it with the parenthesis over here, and you see that the fourth index contains the maximum value. Okay, so this is how it is shown. Now if you see over here, the few things which I wanted to show you was ending. This is the end dimension, the dimensions through which you can call the dimensions. So let me show you enddim attribute. It is 1. So x1 is 1-dimensional. x2 is 2-dimensional. My x3, which was earlier defined over here, if you see, x1, x2 is 3-dimensional. So this is how this dot operator works. So ending we have seen. Similarly, shape is also another attribute. Size is also another attribute. And they are all called with dot. Okay, on the object. Object is our NumPy array. Okay, makes sense? So what I'm going to do over here is I'm just publishing for x1, x2, x3 the ending, shape and size. Okay, let's publish it. Let's see the result. X1, okay, what is X1? Let me just show you also. X1 is my one-dimensional array, 3, 5, 0, so 2, 5 elements, right? So the dimension is 1, correct? Shape is 5 cross 5, comma, and blank. This means that it has 5 elements, okay? And it looks like it is trying to say that it's 5 rows and 0 column, right? But in NumPy, the single dimensional array is neither a column vector or a row vector. It is neither a column vector or a row vector, or you can consider it both. It depends on the context. So it is sort of undefined. But in case of two-dimensional, x2, if you see, the shape was what? 4, 5. Let's print x2. What is my x2? x2 is 4 rows, 5 columns. 4 rows, 5 columns. So it's a two-dimensional vector. What is the size of this? What is the dimension? 2 dimensions. What is the size? The size is nothing but how many elements are there. How many elements? Elements will be 4 cross 5, 20, right? Similarly for x3, let me just put x3 over here. If you see x3, x3 is 3 cross 4 cross 5. Again, to read it from the right to left, 4 cross 5. This is 4 cross 5, right? This is 4 cross 5, this is 4 cross 5. How many 4 cross 5 are there? 3 are there, right? So it's a 3 cross 4 cross 5 dimensional, n-dimensional array is there. How many elements would be there? The dimension will be 3. How many elements? 3 into 4, 12, 12 into 5, 60. 60 will be the size. These are the attributes, endim, shape, and size, which you can use to gather how many elements are there, what is the dimensions, what is the shape of that ND array is. Okay, let's move on. The dir thing I have already discussed with you. What is the dir and how do we make use of the attributes and the methods which are exposed for that particular object. Okay. NumPy 1D array are neither column nor row vectors. This I was just talking a few minutes back, right? x1.shape. What is x1.shape? It is saying 5 comma blank, right? Let's try to do the reshape operation. What is reshape? As the name suggests, you can run x1 dot reshape. Okay, let me remove that and show you. x1 dot reshape. Reshape, the same vector x1 will be reshaped into 1 comma 5. Okay. So what was my x1? Let me show you the x1. x1 was 0, 3, 3, 0, 4. Do you notice that 2 square brackets over instead of 1? So from 1 dimension, it has become 2-dimensional. And the way it has become 2-dimensional is that it has only 1 row and 5 columns. So that's why it is being represented by 2 square brackets over here. Okay. Now let me do the shape of it. Okay. The shape. It will be 1 cross 5, right? So this vector is a 1 cross 5 2D array, right? Similarly, x1 dot reshape 5 cross 1. Okay. Now I can make it 1 cross 5. That means 1 row, 5 columns. I can also make it 5 column, 1 row. 5 rows, 1 column. Let's see. And let's see the vector also over here. You see how it is represented. Again, starting with 2 square brackets, but this is 5 rows, single column. So this is a column vector, right? But in its initial shape, which was what it was, 5 comma dash 1D array. These are 2D arrays, right? These became 2D array. This is also 2D array, 2 dimension. But in 1 dimension, it was neither column nor row vector, right? And we'll just see it in a minute that why it is like that. Now let's see how the indexing works. Indexing works pretty much the same way how Python in Python list indexing works, right? X1. So you index, it is 0 based indexing, and you access the first element with 0. Like if I have to access this element, I will put 0. If I have to access the second element, let me run that. Second element, which is index 1, I will access 3. So 3 will be accessed. Similarly, x1, 4 will be accessed, right? 0, 1, 2, 3, 4. Fourth index is 4. Okay. To index for, again, like Python list, the negative indexing works. So the last element will be -1, right? So x1 -1, 4, right? x1 -2, second last element 0, second last element 0. Similarly to Python list. Okay. In a multi-dimensional array also it works the same thing. So what is x2? X2 is a two-dimensional array, right? Now x2 0 0. What will be the x2 0 0? Similarly, 0th row, 0th column, right? What is 0th row, 0th column? 1. Similarly, x2 2 0, x2 2 minus 1. Second row, 0, first, second row, and the last column, 7. This is 7 over here, right? Okay. Values can also be modified using one of the below index notations. So either you do this and you can modify the index. Using index, you can assign new values also. So x200, which was my x200, and then if I call x200 was 1, right? I'm assigning 12 over there. 12 came, right? Keep in mind that unlike Python list, NumPy arrays have a fixed type. This means, for example, that if you attempt to, so it's the same thing, right? NumPy arrays are homogeneous. Python lists were heterogeneous. It has to be upcasted, right? So D type is int64. If you try to assign x1 0 and a value of pi is float here, right? But what was my data type of the NumPy array? Integer. What will happen? It will truncate that value, make it integer, right? See what is happening over here? Because the data type of my array itself is integer, I have to truncate this to make it integer. And the way to make it integer, that they just truncate the decimal part and keep it, right? Similarly, if it is float, x1 float, and if I have to put this over here, right, it will automatically go because my data type was float and I'm trying to insert a float. No problem over there. Okay. Now comes the slicing. What is slicing? If you want to if you just want to slice the array and you just want a section of it, a piece of it, right? Very much like Python list, this also works. Start, stop, and a step size, right? So you have already seen the arange function. What it will do? It will create 0 to 9, right? It will create 0 to 9, an array 0 to 9. Let me run that. What is this x5? How this can be read? Start, if nothing is mentioned, that start from the beginning. Beginning is what? 0th index. Start from the beginning, go till 5th, but not 5th, before that, right? 0th element, first element, second element, third element, fourth element, not 5th. The end is excluded of, right? So not 5th element till here, right? That's why it is included like this. Okay. Why 5 is not appearing over here? Because index 5 is exclusive. The end is exclusive. Beginning is including, right? So here 5, that means this index will be included, and nothing is mentioned that go all the way till the end, right? 4 7, start at index 4, 0 1 2 3 4. Start at this and end where? 4 5 6 7, right? Start at end, but 7 is not included, so till here. So 4 5 6 will be included, correct? This is start from the very beginning, go all the way till the end. Both are missing. A step size is mentioned as 2. That means skip 1 and move. Skip 1 and move. Skip 1 and move. Skip 1 and move and go all the way till the end. Correct? Makes sense? This is starting at 1, first index. Not the zeroth, but the first index. Go all the way till the end. Skip other, right? 1 3 5 7 9. It's pretty intuitive. Okay. Similarly, like index, if you have to reverse, this cool trick is still there in the NumPy also with -1, because what will happen with -1? You are counting from the backward, right? So all the elements will be reversed. Okay. Now let's reverse it and see. Okay. Now when you reverse, all elements are reversed, right? But when you do x, x is still there, right? X is unchanged. That means this particular thing is creating a copy of it. You see, it is creating a copy, but it is not doing in place. It is not doing in place, right? So if you have to do something like this, then maybe you have to assign it like this and then do x, right? Otherwise it was just creating a copy. Okay, multi-dimensional subarrays. Now the same concept of slicing, index and row wise and column wise, will work with multi-index also. So x2 was our two-dimensional array. Now the first thing is the array column, row before comma. The second is column, right? The second dimension. So what will be this? Start from the beginning, go till 2, but not 2. Start from the beginning, go to 0, 1, not 2. So these two rows, right? It's selected. 3, start till the beginning, go till 3. So 0, 1, 2, 3, not this one. So it is only this particular 1204 and 722, right? 1204, 722. Understood? It's the same concept, exactly the same concept, right? This is all the rows, all the columns, but alternate columns, right? Similarly, reverse row, reverse column, correct? Accessing array row and columns. First column x2. How you'll know this is the first column? 0. All the rows, only one column, 0 column, right? One row, all the columns. Okay. Print x2 0, equivalent of x2 0, comma. What is this thing? We are not mentioning anything after comma. If you are not mentioning anything after comma, that means it will assume that you are asking for all the columns in a multi-dimensional. There are two dimensions. There should be a comma over here, right? For the columns. If you do not mention it, that means you are asking for all the columns. So it will retrieve you first row, all the columns, right? Subarrays. Now what is subarray? Subarray is a slice, is a section, right? Is a section. So one important, extremely useful thing to know is that slices are views. Whatever you are creating, these are only views. Okay, this means that one area in which it is only giving you a view of that section. When you know the view, that means it's coming from the same memory, right? And if you update this view, the original numpy array will also get modified. Okay, we'll see that in action. Print x2 over here. This is a two-dimensional array. Now I'm creating a x2 sub out of this, right? So what I'm doing, start from the beginning for the row 0 and 1, 0 and 1, right? These two rows, and only 0 and 1 column. So 12 0 7 2, 12 0 7 2, it should be, yeah, 12 0 7 2. I'm only getting this section, right? So this is my sub array. I'm taking a slice out of it, right? A sub array, and this is a view. So let's modify this. Okay, so at column 0 0 into x2 sub, which was my slice, which was my sub array, I'm modifying the element as 99, right? 0 0 element. I modified it. It got modified, no problem. What I'm doing over here is I'm trying to print x2. You see, x2 was 12, right? 0 0. It became 99. That means my sub array is only a view of this. I was getting a section of this, but it is also belonging to the original array. If you modify this view, the original array also gets modified. So this is the default behavior, right? And why it is important? Because suppose you are doing data pre-processing, right, or EDA process. You do not want to manipulate the whole data set or the whole NumPy array. You only want a section and you want to manipulate. And then if you have to do, let's say, if you want a separate copy in memory for that particular subarray, then you have to do explicit.copy. If you do explicit.copy, it will create a completely new array. Okay, and when you modify after that, see, I updated 42 over here, but it retained 99, right? It didn't modify because it is this sub array is a copy, is not a view. So if you have to do copy, be sure that you use dot copy. Okay, simple. Reshaping. How do we reshape the array, right? We have already seen that sometime before. Now this particular np.arange, right? Let's just see this first. Let me just show you this. What this will print? This is an array which is 0 to 9, right? starting 1 because we mentioned 1 over here. So 1 to 9, 9 elements. And then I put a reshape over here. So this particular array, and I'm reshaping into, what is the size? I'm demanding 3 cross 3. So 9 elements were there and 3 cross 3 matches. So I'll demand 3 cross 3. And what I'm doing finally, I'm storing it into grid or something, a variable called grid. Okay, so I'm grid, and then I'm printing the grid, right? So this is 3 cross 3. Let me show you that what happens. If it's 3 cross 5, the size will not match. Here we are getting only 9 elements, and here we are expecting 12. Let's see what error it throws. Cannot reshape array of size 9 into shape of 3 cross 4. It has to match. Okay, keep that in mind. Okay, this is the reshape thing. So a quick example, like what we have seen before also. This is np.array 1 to 12 elements. Okay, and I'm doing the, let's see over here. What I'm doing the x, shape, ndim, and size 12, single dimension, 1, 12 elements, right? After that, I reshaped into 4 into 3. This is my 4 into 3 array. Reshape, shape is 4 3, dimension is 2, size is 12. Size will remain same, correct? It's just a reshape. I'm moving it to 2 cross 2 cross 3. Again, 3 to the 6, 6 to the 12. Size has to match, otherwise it will throw exception. Again, my shape is this, dimension is 3 dimension, size is 12. So you can reshape your array as long as you are not doing any error with the size calculation, right? You feel free to do reshape into a single dimension, into multiple dimension, 2 3 or more dimensions. That's fine. Okay, size, shape, and dim. List has commas, nd array doesn't have it. Okay, so what does it mean? It's just something which probably you will notice over a period of time. I just wanted to show you. So this is a list, right? When you print the list, it has commas over here, right? Age list. When you define an array and you print it, there is no comma inside this. The array also comes with printed with this brackets, right? But there is no comma. This is something which you notice over a period of time. I noticed this. And the type of X is ND array, right? NumPy 1D array doesn't have row or column concept. We have already seen that. Okay, let's see that what it actually means. There is something called transpose. Transpose is when you reverse the row into column and column into row, right? When you reverse, that is the concept of matrices. If you have seen matrices, that is the transpose of the matrix, right? You just flip it across, like the row becomes column and column becomes row, right? So that is represented over here with the dot t operator. So what is my x? My x is a one-dimensional array. What is the shape of x? Let me show you. X dot shape 12, and if I do a transpose of this, it remains 12 comma. So if it would have been column matrix or column vector, it would have become row. If it would have been row, it would have become column, but it retained the shape. See, the shape is exactly same with the transpose, no change. That means that both the column vector, the one-dimensional array in NumPy is neither a column vector nor a row vector. It's just a vector. That's it. Okay. Okay. Now there is something called axes. When we go to multi-dimensional, there is something called axes. Now for a single dimensional array, this is axis 0, and we'll just see that what it means. Axis 0. Okay. There is only one axis, and that is axis 0. In two-dimensional array, this is axis 0, and this is called axis 1. So columns are axis 1, axis 0, rows are axis 1. Similarly, in three-dimensional shape, my columns are axis 0, rows are axis 1, and the third dimension is axis 2. Fourth and beyond dimension, I think we cannot imagine, we cannot humanly see that, but similar logic applies over there also. Okay. Now, why this is important, right? Okay. Now you can do that. Sometime what you can do is that you can actually transfer. One is the reshape option, right? You can do x dot where is it? You can actually do the reshape functions, right? So let me do reshape. What you can do is something like this over here. Okay, so x, and x is what? How many elements are there? X dot size 12. So what you can run is x dot reshape, and you can do 3 into 4 easily, right? No, 1 second. Yeah, x dot reshape 3 into 4, and it became a nice 3 rows 4 column 2-dimensional vector, right? 2-dimensional matrices, right? You can do that also. The other way to do that is you can, there, since you can have a new axis also. So the way to do that is np.new axis, okay, and then colon. Colon is that all the things which were there, right? All the elements, right? And then you are creating a new axis. When you created a new axis, do you see that what is happening over here? 2. That means it is becoming from a single dimension to 2-dimensional. That's why 2 square brackets are coming, right? So it became, and if you do a shape of this 112, it is coming as 112. Why it is coming 112? Because now you have added a new, it has become like a 2-dimensional array, but having only one row. Only one row, but it is still a 2-dimensional array, right? That's why the shape is 112. Okay, pretty standard. Okay, similarly, you can do it with the reshape as I was showing you, right? With the reshape option, you can do, right? Let's move on to concatenation or splitting, how we join or how we split, right? For that, let's take 2 examples. I'm defining x and y, right? 2 arrays, single dimensions, simple, right? When I do np.concatenate x, y, this is how you concatenate, right? You pass it through a list x, y, and when we join it, you join it since these are both single dimension, it is joined one after the other, right? No confusion. You can join multiple also, like x, y, z also, as long as they are single dimension, because if they are one dimension, so it has to be appended one after the other, right? Just like strings would be concatenated. But if it is 2 dimensions, right, then along which axis it has to be concatenated, right? That becomes the question. What are the axes? When it's 2 dimension, this is axis 0, this is axis 1. So suppose there are 2 such things, whether it will join over here or over here is the question, right? Now let's see that how it works, right? So when we do np.concatenate and we pass 2, like this is my grid, right? This is my grid, and I pass grid and grid. What it did one on top of another, one on top of another. That means it has done on the axis 0. It has done on the axis 0. And if you see the help over here, let me just show you. I think it should be mentioning over here. Axis. The axis along which the array will be joined. If axis is none, arrays are flattened before use. Default is 0. So default is along axis 0, right? And if you mention none, then it will be flattened. Flattening means making it single dimensions. Okay. Now, if you want to add it like not one on top of other, but the sideways, right? Like this, what you define, axis is equal to 1. Axis is equal to 1 is what? This direction. So you append one after the other, right? And that's what is happening over here. Axis is equal to 1, right? For working with arrays of mixed dimensions, it can be clear to do np.vstack. If you have mixed dimension, then you can do vertical stacking or horizontal stacking. Vertical and horizontal stacking. Okay. So let's say you have x as this. X is what? Your 3 cross 3 comma. It's a one dimensional, right? 3 comma null, right? And this is your 2 cross 3. If you do a vertical stacking, this is the V stack, right? You do X and grid. Vertical stacking means one on top of other. This one goes first, this one goes after, right? Similarly, horizontal stacking, one after the other on the axis 1. This is axis 0 vertical, horizontal is axis 1. Similarly, for splitting, what do we do? The opposite of concatenate is split, right? How do we split? You specify, this is my X array, right? You specify 2. What it will do is the number which you mention over here, it will split into that many parts, okay? So n dot split x2, when passing an integer, it will split that in that many parts. So this whole thing will be split into 2 parts. 1 2 3 9 0 1 2 over here and over here, right? Split into 2 parts. When passing a sorted list, it will divide the array into these indexes, okay? So if I am passing my x is this, right? My np dot is split, and I'm passing a list over here, not an integer. Integer, that means that many part it will divide. If I pass a list, what will happen over here? Think. What it is saying that it will divide the array in these indexes. So the list will be the indexes. So what is my first index as a split? 0 1. So 0 1. This is my first split at this point. What is my second split at 5? 0 1 2 3 4 5. This is my second split. So I'll split at 2 and 3, right? So 1 2 3 9 9 2 3 9 9. Again the third split as 3 2 1. Okay, which is essentially the same thing as writing it like this, if you think about it, right? It's the same thing. So if we are mentioning two indexes of a split, effectively it will be split into 3 parts, correct? 1 5. These are the index where the split needs to happen, okay? Either you can do a split like this, or you can do slicing like this. It's the same thing, right? Okay, this brings us to the end of this video also. I'll see you all in the next video. Thank you. Bye.